Given question, three cylinders are piled up in a rectangular channel as shown. Determine the reaction R between cylinder A and vertical wall of the channel.
Let us understand the given data. If we observe the diagram, there are three cylinders A, B, C that are piled up in a rectangular channel. Now there are the points 1, 2, 3, 4, 5 and 6. These are the point of contacts in between the cylinders as well as in between the cylinder and wall. Now we have to find out the reaction at point 6. If we observe the given data, there is the radius and mass of each cylinder is given. Now we know that weight always acts in vertically downward direction passing through the center. So from this given mass we have to calculate the weight. So for cylinder A, radius is 4 cm, mass is 15 kg. So weight is equal to mass multiplied by G, that is mass multiplied by 9.81. So it is equal to 147.15 Newton. Now in the same way for cylinder B, radius 6 cm, mass 40 kg, weight 392.4 Newton. Then for cylinder C, radius 5 cm, mass 20 kg and weight 196.2 Newton. Now if we join the centers of each cylinder, that is the center A, B, C with each other, then here I will join the centers A to B and then B to C. Now we have to find out the angle of inclination of these centers with the horizontal line. So I will draw here one horizontal line passing through the point B. So I will make here, this is R and here is S. Now if I extend this point C in downward direction, so for this horizontal line, so I will draw this construction with the help of black marker. So if I extend this C to the horizontal line, so here is the point of intersection, this point I will say D, and if I extend this line passing through this point A on this horizontal line, so here is the point of intersection, I will say E. Now we have to find out the angle of inclination of this line BC with the horizontal line RS, we will say theta 1. In the same way we have to find out the angle of inclination AB with this horizontal line, we will say theta 2. Now we will make here one triangle. So for this angle theta 1, I will highlight this triangle. So if we observe, we can say that cos of theta 1 is equal to this BD divided by BC. Now how to find out the exact value of BD? Now here is the center. Center we have extended. So from this center, that is C and D, if we observe, what is the distance from this point C to the vertical wall? So this distance is nothing but this R to D. This R to D distance. And here from B to S. So to find out the distance from B to S, we have to use the radius for the cylinder B, that is 6. So how we can define this BD? So BD is equal to this total distance RS minus this RD minus BS. Now this RD is equal to radius of the cylinder C, that is equal to 5. And this whole distance RS is mentioned in the question, that is 18 centimeter. So we will use this data and we will find out the value of theta 1. So cos of theta 1, we will say that RS is equal to 18 minus RD, that is 5, minus BS, that is 6, divided by BC. So BC is nothing but we have to add these two radius, that is radius for this cylinder B and radius for the cylinder C. So 6 plus 5, that is 11. So theta 1 is equal to 50.48 degree. And we have to note down this value. Now in the same way we will calculate this angle theta 2. Now I will highlight this. So how to find out this angle theta 2? So I will join this line B to A. Now from this A we will draw here one vertical line, that is A to E. Now I will join this B to E. So in the triangle BAE we have to find out theta 2. So we can write here cos of theta 2 is equal to, so this is the right angle triangle because here is the perpendicular lines. So cos of theta 2 is equal to BE divided by AB. Now how to find out BE distance? So if we observe, we have to take here this total distance RS minus RE minus BS. Now if we observe, this RE is nothing but, because point E and point A lies on the same vertical line. So this RE distance is nothing but the radius of the cylinder A. So RS is equal to 18 minus radius of cylinder A 4 and radius of cylinder B, that is 6. So we have to use this, that is 18 minus 4 minus 6 divided by AB. So AB means radius of cylinder B plus radius of cylinder A. So B and A, that is 6 plus 4, that is 10. So when we calculate, we will get 0.8 and therefore theta 2 is equal to 36.87 degree. We are going to draw the equilibrium diagram. We will draw three circles with center A, B and C. Now if we join this center B and C, then it is making angle theta 1 with this horizontal line. So here we will mention angle theta 1. And if we join the center A to B, then it is making angle theta 2 with the horizontal line. So we will mention here angle theta 2. Now we will show the reaction forces. So if we observe the cylinder C, then it is in contact with the vertical wall at point 1. So reaction force will be in horizontal direction because the reaction always perpendicular to the surface and towards the cylinder. So I will show here the reaction. So it is at point 1. So we will show here as a R1. Now cylinder B and cylinder C is in contact with at point 2. So we have to show the reaction. So reaction force acting towards the cylinder C, and it is along the line BC because BC is the line joining the center of the two cylinders. So we have to show here. So it is the point 2. So we will show reaction R2. Now in the same way, if we observe the cylinder B, then this reaction force at point 2 we have to show towards the cylinder B, and it is along the line BC. So we will show here R2. So this R2 is equal in magnitude but opposite in direction. Now cylinder B is in contact with vertical wall at point 3. So we have to show the reaction. So reaction should be perpendicular to the surface. That means we have to show here reaction in horizontal direction and towards the cylinder B. So it is R3. Now cylinder B and cylinder A is in contact with each other at point 4. So we have to show reaction force at point 4, but it is along the line AB because AB is the line joining the center of the cylinders. So for B we will show the direction towards the cylinder B and it is R4. In the same way, towards A we have to show the reaction force R4. So this R4 is equal in magnitude but opposite in direction. Now this cylinder A is in contact with horizontal surface at point 5. So we have to show reaction perpendicular to the surface, that is in vertical direction, and direction is towards the cylinder A. So here we have to show it is R5. And we have to find out the R6 where the cylinder A is in contact with vertical surface. So we have to show horizontal reaction force and it is R6. Now this R6 we have to find out. Now if we observe, to calculate this R6 we require to calculate R4, and to calculate R4 we require to calculate R2. So in this diagram, how to find out R6, because R6 is also related to R4 and R4 is related to R2, which is all the terms are unknown terms. So we have to find out. Now there is also weight, and weight always acts in vertically downward direction passing through center. So this weight we have to consider in this diagram, and we will show this. So for cylinder A, it is WA. So this R phi is in upward direction and this WA is in downward direction, and it's a 147.15 Newton. So we have to show this. Now for cylinder B, we have to show in downward direction, and it is 392.4 Newton, and for cylinder C it is 196.2 Newton. We will calculate reaction R2 on cylinder C. If we observe, there are three forces R1, R2, and this weight 196.2 Newton, and these all forces are passing through a single point. So we can apply here Lami's theorem. So to apply Lami's theorem, we have to rearrange these forces. So we will consider this point C, and from this point C, this R2 is passing in outward direction. That is, we have to arrange all the forces in such a way that they should pass through in outward direction from this common point C. Now here we will show the weight W that will act in downward direction from this point C, and R1 that will also move in the outward direction from this point C. Now for this diagram, we can apply the Lami's theorem. Now if we observe, here is the horizontal line, and this is also horizontal line for the cylinder B. In between these two horizontal lines, there is common inclined line BC. Here is angle theta 1. So this opposite angle also equal to theta 1. So this angle theta 1 is made by the reaction R2 with the horizontal line. So in this Lami's theorem, if we rearrange this diagram, then this R2 is also making same angle theta 1 with the horizontal line passing through the center. Now we will write here R2 divided by, so R2 divided by sine of angle between other two forces. So this angle is 90 degree, which is equal to R1 divided by sine of angle between other two forces, that is this 196 and R2. So it is 90 plus theta 1 is equal to this 196.2 divided by sine of angle between R2 and R1. So if we observe, along this horizontal line, this total angle is 180, and if we take 180 minus theta 1, then we will get this angle. So when we solve this, because we know the theta 1 is equal to 50.48 degree, so when we solve, we will get R2 is equal to 196.0.77, and the sine of 90 is 1, and which is equal to 254.34 Newton. Now it is not required to calculate R1 because R2 is connected to cylinder B. So we will move to the next cylinder B. Now for this cylinder B, if we observe, there is R4 which is also connected to cylinder A. So we have to calculate R4. Now we will resolve this component R2 and R4 into vertical and horizontal direction. So I will resolve R4. This is the horizontal component and this is the vertical component. Now if we observe, theta 2 is the angle made by the R4 with horizontal line. So for this horizontal component and this horizontal line are parallel to each other. So here is also angle theta 2. So what is its value? So we can write here as a R4 cos of theta 2. R4 cos of theta 2. And for this vertical component, R4 sine of theta 2. Now in the same way we will resolve this R2. So how to resolve into horizontal and vertical component? So here we will draw one horizontal and one vertical line, direction in the same direction of R2. Now how to decide angle? So this horizontal line and this horizontal component are parallel to each other, and this is the common line. So this angle is theta 1. So for this horizontal component, R2 cos of theta 1, and here R2 sine of theta 1. Now we will take summation of all vertical forces is equal to 0. So vertical forces are this r4 sin theta 2, direction is upward, so we will take positive sign. r4 sin of theta 2. Now r2 sin of theta 1 having negative direction because it is in downward direction. So minus r2 sin theta 1 minus 392.4 is equal to 0. Now in this case r2 is known and we have to find out r4. So r4 is equal to 980.9 Newton. Now we will move to the cylinder A. Now if we observe, we have to find out r6, which is the horizontal, which is the force in the horizontal direction. So we will resolve this r4 into two components, that is in horizontal and vertical component. Now we have to decide the angle. So here this horizontal component is parallel to this horizontal line. So if we observe, in between B and A, these two are horizontal line and this BA is the common line. So this angle is also equal to theta 2. And this angle in between R4 and horizontal component is also equal to theta 2. So its value is R4 cos of theta 2, R4 sin of theta 2. Now we have to find out R6, which is the force in horizontal direction. So we will take summation of all horizontal forces is equal to 0. So we will take R6, which is in direction is towards right hand side, and R4 cos of theta 2, direction is towards left hand side. So R6 minus R4 cos of theta 2 is equal to 0. And when we put the value of R4 and theta 2 is 36.87, then R6 is equal to 784.8 Newton, and this is the answer.